Hello, everyone. My name is Timur Doumler. I joined Citadel Securities last year. I work on the low latency team, and I'm also on the ISO C++ standard committee. I've been there for about a decade now. And for the last few years in that committee, I have been working on standardizing another feature that we're now going to get in C++ 26 called contract assertions. So I want to talk a little bit about that feature and why that's really cool. So we all know CAssert, the CAssert macro, or our own homegrown internal versions of some kind of assert macro. I'm sure everybody here uses something like that, right? Who has an assert macro of some kind in their code base? Like, yeah, everybody. So this is what the good old CAssert looks like. We all know this. And in C++ 26, we're going to get kind of a better version of this, which is called contract assert, except that it's not a macro, so you don't have to include a header. And it is actually a keyword, right? And that alone solves so many problems, right? You don't have any problems with parsing in a macro if you use like different kinds of braces. You don't have ODR issues. And also you can use it in a module. It just works, right? So that's great. The code on the left and the code on the right, by default, if you don't specify anything else on the command line, does exactly the same thing. It checks that the condition is true, and if it's not true, it prints an error message, and then it terminates your program. Of course, the whole point of an assertion facility, whether it's like the good old CAssert or the new shiny contract assertion one, the whole point of such a facility is that you can actually configure this behavior, not in the code, but you can delay that and do that configuration at runtime, at compile time via a build flag or something like this. And so for assert, we do this via ndebug. For custom macros, we do this via whatever mechanism you use to enable and disable your assertion macros. And for contract assert, the standard doesn't really say exactly what flag you're going to get because the standard doesn't talk about flags. But in practice, you're going to get something like this is the one that the current GCC and Clang implementations offer. F contract semantic equals ignore is going to turn the check off. And this ignore here, we call this an evaluation semantic. It's like a behavior that the assertion check could have. So that's kind of a new term of art. The good old CAssert has two such evaluation semantics, right? ndebug on or ndebug off. And so it's either on or the whole thing is just macroed out by the preprocessor. In C++ 26, for contract assertions, we actually have 4 options now, so it's more flexible. And each one of those options maps to like a relevant use case. So you've got ignore, observe, enforce, and quick enforce. So ignore does what you would think it does. It ignores the check. It doesn't actually do anything. Then the other 3 are called checking semantics, so they actually check the predicate. And these last 2 are called terminating semantics because they will not let your program proceed past a failed check. Right? So that's very good for things like if you really need your bounce check to happen, for example. And also this print diagnostic bit that observe and enforce do by default. We call that the default contract violation handler, which is provided by the compiler, but that's actually configurable now as well. So you can configure this by installing your own user-defined contract violation handler, and you do that by defining a function with its exact name and signature and linking that into your program, and then in the body of that function, you can do whatever it is that you want to do to handle a contract violation. You can do your own logging. You can set a breakpoint, another little feature that I really like in C++ 26. Or you can, I don't know, spin on whether a debug, like wait until a debugger is attached, and then set a breakpoint. Or you can print a stack trace. Or you can print a stack trace and then delegate to the default violation handler. So this is one of 2 bits of new library API that we get in C++ 26, which is this invoke default contract violation handler. And the other bit of standard library API that we're going to get for this is this contract violation handler object, which is going to be passed into your violation handler. It's created by the implementation, and you get that passed in. And that you can access to figure out what assertion failed, where, why, all kinds of queries like this, which you then might want to log or do something else with. And so that object also comes with like a little piece of library API with a number of member functions that we provide in C++ 26. So this is really cool, but it gets even more cool because the best thing about this is that contract assert is not the only kind of contract assertion. There's actually 2 more kinds of contract assertions, which are called pre and post. And they are even more powerful because you can put them on a function declaration. And this is not something you can do with an assert macro today. And so that actually unlocks a lot of power and scalability. So for example, if you have a function declaration, you can now stick your precondition, postcondition assertions directly there. And so the precondition assertions are kind of the things that need to be true when the function is called. So they're checked when you call a function. And the postcondition assertions are checked when the function returns. And the other feature we have here is that with this new syntax here with the colon, you can directly name the object that the function returns. And so that's not going to be a copy of the return value or a reference to it. It's actually a name for directly, the object that the function returns, which you previously could not name in C++. And yes, it works with return value optimization. Yes, it works with guaranteed copy elision. So that's really cool. That's another thing that you could not do previously with macros. And so, but the really powerful thing is that these things are part of the function declaration, which means you can put them in a header, and they're not in the body of the function. You don't need the implementation. You put them in a header, and everybody sees this. Human developers see this, these assertions. LLMs see these assertions. There's something that we found that actually they greatly help LLMs to reason about your code. The compiler sees it, the IDE sees it, and can display a little bubble. Hey, you're violating a precondition assertion here. Maybe don't do this, right? As you type the code. Static analysis tools without ever having to look at the implementation or even have access to that, right? So that's a lot more scalable than kind of assertion macros that we have today. That's kind of the basic feature set that we get in 26. In 29, there's going to be a number of extensions, more bells and whistles, even more things you can do. Added to that slide is going to be another whole, 1-hour talk that I hope to give later this year. I'm not going to do that now. What I'm going to do in the remaining minute that I have is to talk about why that is particularly interesting in finance. So in finance, we are kind of at this intersection of, on the one hand, performance and low latency, which we really care about, which is what a lot of people are talking about, but then also correctness, right? That is really important, that you can reason about the correctness of your code, because if you have incorrect code running in production, that can very significantly negatively affect the market. So you don't want to do that. And context assertions actually give you this kind of intersection of you have now a way to express in code in a way that the machine understands when you consider your code to be executing correctly, but you still have full control over when or how that's going to be checked and what the performance implications of that are. So that is really, really cool. The other thing, as I said, that because we can put these things in declarations, it's really a lot more scalable and flexible than anything we can do with macros. And the other thing is that this feature has been very, very explicitly designed with this kind of principle in mind that if you have an existing code base and then you add an assertion to it, then the existence or like the evaluation of that assertion is not going to have any effect on a correct program. And so it's kind of designed to be added to existing large C++ code bases, which obviously we have a lot of. And then it can also be deployed component by component, so you can have one translation unit with context assertions, another one without. You can link them together. It all just works. And then the last thing that is kind of particularly important in finance is that this feature actually supports information barriers. So because you can put pre- and post-conditions on declarations, you can now talk about expectations on the behavior of a function without having to expose the implementation of that function. And that is really, really powerful. So yeah, I hope we're going to approve C++ 26 next week at the committee meeting, and we're all going to get to use these cool new features. And I'm very much looking forward to that and excited about that. So that's all I have for today. Thank you.